Hello, welcome to Maths and Science Unpacked. I'm delighted to have you here. Today, we are exploring our very first major topic, number. In this big lesson, I have divided them into subtopics. So in this particular video, you will be considering types of numbers. It's very important that we are familiar with the various types of numbers that exist in mathematics. And this is the very thing we will be doing in this lesson. So stick around to the end and be sure to get a full picture of what we are talking about when it comes to the various types of numbers in mathematics. Thank you. In this topic, you will get to understand what numbers are, how they differ from each other, and how they can be handled to solve any complex mathematical problem. So I have put them together nicely under 6 main topics. So here are they. We will be going through each of these topics one after the other. So the major topic here is numbers, and this is the first part. We will have a second part on the topic numbers. But in this first part, we will be looking at types of numbers, BODMAS, multiples, factors, powers and roots, prime factors, HCF and LCM, fractions, decimals and percentages, and negative numbers. Now you will subsequently understand why I'm taking my time to unpack everything about numbers, because once you get a firm grip on the concept of numbers, you will see that subsequent more complex topics like algebra, statistics, probability become very easy and relatable. So come with me, let's go through this. The first subtopic we will be looking under this topic is types of numbers. So, types of numbers. It's very interesting to know that there are many types of numbers. In everyday language, we will consider numbers to be just numbers. So numbers are 1, 2, 3, 4, 5, and so on. That is in everyday language. But when we come to maths, there are many different kinds of numbers. This course is designed for high school or secondary school students. So at our level, we will be expected to know certain types of numbers. Some of you will move on from high school to, for instance, A levels, and then some even to the university, where you will delve deeper into mathematics. You will come across even more different kinds of numbers. But at our level, we want to organize numbers under the real number family. So what is the real number family? In earlier video, one of my introductory video, I introduced this topic, real numbers, and we looked at all the subfamilies under real numbers. For the benefit of understanding in detail the types of numbers that we will encounter in our secondary school or high school maths, let's look at this family again. So in maths, we call something real numbers. Okay. And every kind of number that you will ever encounter in maths will be a real number. So that is what sits at the topmost of the family tree, real numbers. Under real numbers, we have two types: rational numbers and we have irrational numbers. As in life, many things often come in twos. So it is either black or white. The position is either on top or at the bottom. We are looking either right or left. When we come to mathematics and we are talking about numbers, we are starting from real numbers. And in real numbers, we are either looking at rational numbers or irrational numbers. So let's continue. Under rational numbers, we have many different kinds of numbers. Okay. The first one are integers. Integers, very important in mathematics because that is the definition for a scope of a wide range of numbers, all the way from negative numbers, okay, as far back as you can go into the negatives on the left hand side on the number line. And then you come to the middle, which is 0. And then as far as you can go to the right hand side, positive numbers. So integers are basically negative numbers, 0 and positive numbers. So we will be looking at this in more detail as we build upon the foundations of numbers. The second family under the rational number family are whole numbers. Whole numbers. In maths, when we talk about whole numbers, we are looking at numbers that are not negative. So when we are talking about whole number, negative numbers are not whole numbers. Negative numbers are integers. They are not whole numbers. Whole numbers are the positive numbers: 1, 2, 3, 4, 5. They are not decimals. We will come to that and we will understand what decimals are. But whole numbers are not decimals. But what we often forget is that 0 is a whole number. So in maths, when you are asked to list a set of whole numbers, don't forget to include 0. 0 is a very funny number in mathematics. It is very weird. It can give very complex problems, but it's also a very interesting concept in mathematics. And you can read more about the concept of 0 in mathematics. You will be interested to know that when scholars began putting together concepts of mathematics, 0 wasn't included. There was nothing to define nothing. If you get what I mean. 0 is a relatively new concept in mathematics. Ancient mathematicians did not have anything to define nothingness. They didn't know about 0. It makes an interesting reading. I will encourage you to search more on the concept of 0 and how it has come about to be a very vital part of mathematics. So whole numbers are 0 and positive numbers. Then there are even more members of the rational family. There is something called natural numbers, okay? And much as all these rational numbers look similar, it is important that we understand it here and now because some of the more complex mathematical problems present these terms and they expect that being a secondary school level mathematics student, you should be able to understand what they are. So, for instance, you can get a question, and part of the question is list a set of natural numbers that are applicable to the equation, and so on. In that question, if you do not know the difference between integers and natural numbers, or whole numbers and natural numbers, you may find yourself a bit wanting. And so, in this very first topic, it is important that we take note of all these types of numbers and be familiar with them, so that as we build upon and go to the more complex topics, when they are introduced, we know exactly what they are. So natural numbers are also very interesting. We also call them counting numbers. Okay. Naturally, when you want to count something, for instance, if I give you $100 notes and you want to count them, you start counting 1, 2, 3, 4. Naturally, you will count from 1, and naturally, you will count in positive numbers, right? So, for instance, if you go into a new city and you are trying to locate your hotel, and they give you the street number and you get onto that street, you will start counting from 1, 2, 3, and so on. You will not normally be expected to see negative house numbers, because negative is not part of natural or counting numbers. You will not see anything starting with 0. Natural counting numbers start with 1. So counting numbers are positive whole numbers without 0. They don't include 0. So that's the fundamental difference between whole numbers and counting numbers. Now, my board is being populated, so let's zoom in and zoom out and create more space for the rational number family. What are the other members of the rational number family? We have what we call decimals, but not just any decimals. Not just any decimals, because when we go to the other side of real numbers, when we start talking about irrational numbers, you will also see that decimals appear in irrational numbers. So let's look at the kind of decimals that are part of the rational number family. 1, we have something called terminating decimals. So a decimal that terminates, for instance, 0.45 is finished. All the decimal is 0.45. Or you can also have a decimal that is not terminating, but it is recurring in a very structured pattern. So I can have what we call recurring decimals. An example, 1.27272727. It goes on and on and on. It does not terminate, but we can see a structured pattern in the numbers that follow the decimal point. Another example is 0.2456, 2456, 2456, and so on. We can see that although it is not terminating, it keeps recurring. When that happens, it is a rational number. So these are what makes the rational number family. But we have forgotten to do one thing. What at all are rational numbers? In mathematics, if we introduce any term, we have to define it. And in my kind of mathematical lessons, I don't assume knowledge for everything. Everything that I introduce, I'll take time to unpack it. That's why this channel is called Maths and Science Unpacked. we won't leave you wondering about anything. We will always give you the bare facts, and that will be useful for your learning. So, rational numbers are simply numbers that can be expressed as fractions. It's very important. If you are ever called upon to define what rational numbers are in mathematics, it's simple. If I can write the number as a fraction, it is a rational number. So 2/7 is a rational number. 0.3 is a rational number. Why? Because 0.3 is actually a fraction called 3/10. So 0.3 is a rational number. How about 7? 7 is a rational number. Why? Because whole numbers, strictly speaking, are fractions. And what do we mean? Every whole number is a fraction where it is divided by 1. So, for instance, 7 is actually 7/1. And when you come to certain topics in mathematics and you start solving them, you realize that it becomes clearer and easier for you to express whole numbers as fractions so that you can have it matching with other parts of a problem that are expressed as fraction. A fraction is simply a number that is written as a numerator divided by a denominator. And we will be coming to fractions. If you recall the introduction of this topic, one of the subtopics that we will be looking at fractions. So I don't want to digress so much into going into what fractions are. But for this time, you simply need to know that numbers that can be expressed as fractions are rational numbers. So we have rational numbers, and we now have a detailed understanding of what rational numbers are. And what are we talking about? We are looking at the types of numbers. This will often be the very first topic you will ever be introduced to in mathematics. I know different schools have different approaches to teaching maths, but from my decades of experience in teaching maths, if you get students to really have a firm grip of what type of numbers there are in mathematics, it helps a lot. It helps a lot. It helps solve many problems that we will otherwise encounter on our journey through mathematics. So let's continue. Now, rational numbers. Rational numbers. We have finished with that one. We are looking at irrational numbers. Irrational numbers. Let me make that the green thing so that they are distinguished from the red team. Irrational numbers. What are irrational numbers? So you remember when I started talking about real numbers, I said that in this world, many things come in opposites. Okay, so if rational numbers are numbers that can be expressed as fractions, then we can safely conclude that irrational numbers are numbers that cannot be expressed as fractions. Numbers that cannot be expressed as fractions. Yeah, as simple as that. And sometimes in mathematics, we can use logical reasoning to answer some questions that we do not even know about, right? Rational numbers. The opposite is irrational numbers. So if I've defined rational numbers to be numbers that can be expressed as fractions, then obviously irrational numbers should logically be numbers that cannot be expressed as fractions. And even if you didn't know and you used logical reasoning, then you can correctly define what irrational numbers are from what you know about rational numbers. So it's very important that we understand what irrational numbers are, because if we will come to certain topics where we may encounter irrational numbers, and it is very important that we are confident in handling irrational numbers. There aren't many subtypes of irrational numbers because, come on, they are very difficult. And once you are irrational, you are just one family. It's just like what we have in this world. If you have, you can have different kinds of friends. Okay, some friends that are very helpful, some friends that will support you in many things. But you can also have some friends that are irrational. And those irrational friends, you see that they will all be the same, irrational. They are simply irrational. They are simply difficult to handle. And so irrational numbers are simply numbers that cannot be expressed as fractions. And examples, we have very interesting examples of irrational numbers. I can think of two immediately that are relevant for you at this level of mathematics. The first one is pi. Pi is a very, very important number in mathematics, especially geometry. And in geometry, especially when we begin to talk about circles. Circles are plane figures, and we know what circles are. Now, the value of pi is 3.14 and so on. There's something interesting about pi. We have not been able to really see where pi ends. With all the advancement and computing power our generation has seen, we still don't know where pi ends, and that makes it a very interesting number. If you want to set off on a journey to find the last number in the decimal after pi, you will have a really, really long way to go. You can make it a lifetime mission, and then right from your secondary school days until you go on retirement, you could be looking for where pi ends, and you probably won't find it because it simply doesn't end. And that is the basis of irrational numbers. Because they are not terminating and because they are not repeating decimals, we just can't express them accurately as fractions. And that is what irrational numbers are. So I've recently read a lot about pi, and I've realized that scientists have been able to figure out 60 trillion decimal places for pi, and they are still counting, and it has never ended. Imagine 60 trillion numbers after the 3, and they don't repeat. They don't repeat. They are very unique patterns, and they keep making unique patterns as you go on and on and on. So that is a very interesting concept. The other classical irrational number is root 2. Root 2. Root 2 will never end, no matter what you do. You can find the value of root 2, 1 point, blah, 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 blah. It will go on and on and on and on. It will never end. And that is also a classical example of irrational numbers. So here we are. That is the broad picture of numbers. That is the broad picture of the types of numbers. With this understanding of the type of numbers, we are set to build upon them further. So I will bring this to an end as far as the first subtopic of types of numbers are. And we will move on to the second lesson, which is BODMAS. Just to recollect. So we said we are looking at types of numbers. We have just done that. we now have a good idea on the types of numbers and mathematics, we are now going on to something that is BODMAS. Is very interesting. BODMAS. BODMAS is what will enable us to do operations, and especially multiple operations on numbers in mathematics. And interestingly, when you move all the way across the topics from numbers, algebra, ratios and proportion, probability and statistics, geometry, you will see that you need BODMAS to do operations on numbers, right? And when I talk about operations on numbers, I will explain it when we come to that topic. So let's get ready and go on to the second subtopic in this lesson, BODMAS.